Hello, welcome to this video. In this video, let us take problem on diesel cycle. Let us read the problem. A diesel engine has a compression ratio of 15. So, the value of R is given, compression ratio is 15 and heat addition at constant pressure takes place at 6% of the stroke. So, heat addition at constant pressure takes place at 6% of the stroke. Find the A standard efficiency. Okay. So, we will have to write this mathematically. Now, how do we start this problem? Let us write PV and TS diagram for a diesel engine. So, for a diesel cycle, we will have PV and TS diagram. We know that this is a constant pressure heat addition cycle, PV and TS plot. Okay. We will have first reversible adiabatic compression, then constant pressure heat addition, then again reversible adiabatic expansion, then constant volume heat rejection. Okay. So, this is how a diesel cycle looks like 3, 4. So, this is where heat is added here, heat is ejected at constant volume. Okay. Similarly, if we try to do the same thing here, 1 to 2 will be reversible adiabatic, that is PV power gamma is equal to constant or entropy is equal to constant. Both are one and the same, reversible adiabatic or isentropic. Then 2 to 3 is constant pressure. The constant pressure would look like this, constant pressure. Then 3 to 4 is again isentropic process, reversible adiabatic. So, this is 3 to 4. Then we will have 4 to 1, where again it is constant volume, constant. So, this is where heat is rejected, this is where heat is added. Now, let us look at this. Heat addition at constant pressure. So, heat addition at constant pressure is here. So, 2 to 3. So, that takes place 6% of this stroke. Now, what is 6% of this stroke? Now, look at where the stroke is. All right. Stroke is from here, from 2 to, from here to here. This is what we call it as stroke. All right. So, this is where we are talking about this stroke is. So, therefore, this stroke is Vs, that is equal to V1 minus V2. So, this will be our stroke. Now, what is this? Constant pressure heat addition is taking place between 2 to 3, all right. So, 2 to 3. Therefore, we will have this will be our heat addition taking place at constant pressure. So, this will be our V3 minus V2. So, mathematically if we write this statement, it is given as this V3 minus V2 is V3 minus V2, that is heat addition at constant pressure taking place at 6%. So, 6 by 100. So, the 6% of this stroke V1 minus V2. Okay. Now, that means we can take V2 common here. So, that will be V3 by V2 minus 1, and we can take this will be 0.06. We can take V2 also common here. So, that we can cancel out V2. So, this will be V1 by V2 minus 1. Now, if you look at this V2 cancels out. V3 by V2 is rho cutoff ratio, because V3 by V2 is equal to cutoff ratio. And This will be 0.06. V1 by V2 is compression ratio R minus 1. So, V1 by V2 is compression ratio R. Now, if you look at this equation, I think we have been given with R is equal to 15. The only unknown is cutoff ratio 0.06. R is 15 compression ratio. So, 15 minus 1, and rho is the only unknown. I will find out the value of rho. So, let us solve this equation. Rho I will keep it as unknown alpha x minus 1, alpha equals 0.06 into 15 minus 1. So, shift solve for x is equal to 0 and say that will be 1.84. The value of cutoff ratio is 1.84. So, basically this equation will be given to find out cutoff ratio, that is some percentage of the stroke, that is heat addition happens for some percentage of the stroke, that will be given. So, we will have to use this technique in order to get the value of cutoff ratio. Now, let us go for efficiency of a diesel engine is given by this equation. So, this is already derived and we know that this is the equation which gives us efficiency. If you look at this equation, all we need is compression ratio and cutoff ratio, and the value of gamma for air is already known to us. So, gamma is 1.4. So, I think we must be able to solve this equation. Now, efficiency of this will be equal to 1 minus 1 by this R is now 15, which is given, gamma minus 1, that is 1.4 minus 1, and gamma here 1.4, okay. And then we have rho power gamma, that is 1.84 power gamma 1.4 minus 1. So, be careful here. And then we have rho, that is 1.84 minus 1. So, I think we will take it step by step. I think I will solve the numerator first here, 1.84 power 1.4 minus 1. So, that will be 1.3482. 1.3482, that will be numerator. Then 15 power, denominator will take 15 power 1.4 minus 1 will be 0.4 into 1.4 into 1.84 minus 1 will be 0.84. So, 3.4741. 3.4741. So, this must give us the efficiency of the given cycle. So, 1 minus 1.3482 divided by 3.4741. So, of course, it has to be multiplied by 100. So, 0.6119 R into 100 we will have to do. So, that will be 61.19%. Okay. Thank you.